Hello, I hope you're fine. Welcome to my channel. We are gonna do another identity of trigonometry grade 12. In the first video, we did the compound angles and did the revision for grade 11, whatever. So now you're gonna be doing the double angle. So the identity for the double angles. Shit, my marker is. I have to burn that one. So sine 2 alpha, ne? It is represented like this. It is 2 sine alpha cos alpha. Okay, so that's what you must know. Let's prove it. So sine 2 alpha, ne? It is equals to, it is the same as saying sine alpha plus alpha. You see, alpha plus alpha is 2 alpha. You're continuing. Remember the compound angles we did and it, we expanding it if something like this, and this is plus, so it's gonna be what? Sine alpha cos alpha plus cos alpha sine alpha, and then what do I have? Sine plus sine, cos plus cos. So this and this, they are adding, so it's gonna be the same as saying 2 sine alpha cos alpha. Proven. I'm done. So yeah, let's do the second identity for the double angle. Cos 2 alpha, it is equals to cos squared alpha minus sine squared alpha. So this one, it can be represented in 3 different ways. Okay, the second one is 2 cos squared alpha minus 1. The third one, 1 minus sine squared alpha, 1 minus 2 sine squared 1 minus 2 sine squared alpha. Okay, so let's prove the second one, why we are saying that one can be represented in 3 ways. Okay, so let's do it. Until then I said it must be that. So cos 2 alpha, so it's proving it. So it is equals to cos squared alpha minus sine squared alpha. Okay, so same thing, cos 2 alpha, it is equals to cos alpha plus alpha. You see, again, your compound angle, expand cos alpha minus sine alpha, and then sine alpha, and then cos times cos, it is cos squared alpha, and then minus sine times sine squared alpha. You see, so this one is not a problem. Okay, and then let's prove the second one. Prove with cos 2x, it is equals to 2 cos squared x minus 1. So let's take it from here. I need to value that's already proven, so you're gonna take it from here. Cos squared alpha minus sine squared alpha, okay, it is equals to that one. I mean, this one, it is equals to that one. So cos, let me do this, cos squared alpha and then minus sine squared alpha. We are proving what it is. Cos squared alpha minus sine squared alpha is equals to 2 cos squared alpha minus 1. So I'm used to using x. And then where are you gonna start? I need to mind you wanna prove what this one is equals to 2 cos squared x. So you're gonna leave cos as it is and be cos squared alpha minus, open your bracket. Remember your grade 11 identities. Sine squared alpha is the same as saying what? 1 minus cos squared alpha, close bracket, and then you're gonna expand cos squared alpha minus 1 plus cos squared alpha, because a negative and a negative is a positive, and then you're gonna sort out cos squared alpha plus cos squared alpha, it is 2 cos squared alpha and then minus 1. We are done. And then Lana, you are done. Let's do the third one. So same thing, you're gonna take it from here, because this is the main identity of the cos squared, cos 2x, cos alpha minus sine squared alpha. So now since you wanna prove for sine, you're gonna do what? We're gonna, where there is cos, you're gonna put what represents cos. Then it's going to be 1 minus sine squared alpha, close bracket, minus sine squared alpha. Then it's going to be 1 minus sine squared alpha minus sine squared alpha is going to be 1 minus. So minus 1 minus 1 minus 1, it is minus 2, then sine squared alpha. You see? So that's how you prove them. So, but be careful. Don't just say wherever you come across 2x and then you'll put any of like the one that you feel like you wanna put. No, you don't just choose. You must check how your equation is. If your equation is composed of the cos, that's when you can put what? 2 cos squared x minus 1. If it is cos x, you put this one. But if it is composed of sine squared, sine x, whatever, sine x, if the sine x, you put this one, okay? Yeah. So that's how you do it. That's how you just prove it, and that's how you do it, okay? So let me check something for you. So let's just do this one. Show that 2 sine 15 cos 15 is equals to half. So I have an identity. The first one, which is this one, 2 sine alpha cos alpha. So I have 2 sine 15 cos 15. So what am I gonna do here? I'm simply gonna say sine 2 15, and then it's gonna be what? Sine 30, which is gonna be what? 1 over 2. Proven. So there's nothing much on double angles. There is nothing much on double angles. Like it is just easy, okay? So but we'll be doing more examples and as time goes on, guys, okay? So we'll be doing some examples whereby you have cos exam questions, cos 3x over cos x. When the but prove that cos 3x over cos x is equals to 2 sine 2x minus 1. Okay, so it's gonna be a long one because it carries more 6 marks, 7 marks. So let me do it on my own, and then I will explain. Or do you want us to do it? Okay, let's do it. So this, since it is cos 3x, I must say cos 2. Let me start on a new page. So until now, I was saying 3x can be represented as cos 2x plus x. You see, over cos x. We're continuing. This is an identity, the compound angle. You have to expand it. It's going to be a long work. This one. Then it's going to be cos 2x cos x minus, this is plus, sine 2x sine x. Okay. And then we're going to continue over cos x. This is an identity. This is an identity. We have to open the two identities. It's gonna be a lot of work to do, I'm telling you. So it's gonna be that. So cos 2x can be represented as what? Cos squared alpha minus sine squared alpha, this and that and that. But manje, I can see with manje this is cos and that is cos, so I can choose this one, which is cos squared alpha, because this is cos and this is another cos. So it's gonna be open bracket 2 cos squared x minus 1 times cos x, and then minus, this is an identity again, sine 2x. Okay, so let me try it and then say 2 sine x. Must I my 2 sine x cos x, and then times what? Sine x again, because it was already there, and then over what? Cos x. Okay, you see what is now happening right now. You're gonna continue. This is a proof, and don't forget, this is a proof that this is equals to that. Okay, so this is an identity, so I must open the bracket by multiplying with that. So it's gonna be 2 cos cubed x minus cos x, because 2 cos squared x times cos x, it is the same as cos times cos, it is 3, and then minus 1 times cos, it is minus cos x, and then it's gonna be what? I come to this side, minus 2 sine x cos x times sine x. It will be what? I'm gonna write it here, okay? Minus 2 sine x cos x times sine x, everything over cos x. And then we are gonna continue. 2 cos cubed x minus cos x minus 2 sin cos x, whatever. So what is common there? 1 2 3 1 2. So what is common? It is cos. I'm gonna factor out cos, which is gonna be what? Cos x, open bracket. So lana, when I divide by cos, it's gonna be 2 cos squared x, and then minus this and that, they cancel, so then it is nothing, minus 2 sine x times sine x. This cos is now gone, and then all over cos x, then I will cancel the 2, then I'm gonna be left with 2 cos squared x minus 2 sine squared x, because sine x times sine x, it is sine squared x. Then already I can now see myself with I have an identity, which is what? This one. But mind it is 2, so this 2 is gonna be outside, and then cos squared x minus sine squared x, it is what? Cos 2x. And then wait, I left something there. Yeah, there's something that I left. It must be, there's something that I left, guys. Where is it? Oh, it must be minus 1 here. Sorry, I forgot. Minus 1, then minus 2, because this and this over cos x cancel kusala 1, so minus 1. Then this one will go to the other side, then it will be 2 cos 2x minus 1. That one that was there. So it is already proven, you see. So that's how you can play with maths, guys. Okay, so thank you, guys. So we'll be doing more questions and more examples as time goes on, past papers and stuff. Thanks.